Welcome to my presentation. In this presentation, we are continuing to solve system of linear equations using the matrix methods. We are looking at example 4. We did part 1 in the previous playlist, and now this is part 2 of that. We will continue um, from where we left off in part 1. We left it off at this point. We will continue from this point on, and the place where we left off is at this point. Let me write that matrix down. 1, -2, 3, -7, 0, 3, -7, 21, and then 0, 1, 5, and -15. So this is where we left it, and then we will continue from this point on. Okay, so in here we want to make this location equal to 0, and then we will use the row operations to arrive at that location as being equal to 0. So we have 1, -2, 3, -7, then 0, 3, -7, 21. That is the second row, and the third row we're going to write it out as follows. R3, the new R3 is going to be equal to R2 minus 3R3. That's the way we want to do it. So R2, 0 minus 3 times 0, which is still 0. Then 3 minus 3 times 1, which is equal to 0, and then minus 7 minus 3 times 5. So this is going to be minus 7 minus 15, which is equal to minus 22, and then we have 21 minus 3 times 15, 3 times of minus 15, so this will be 21 plus 45, and this will be equal to 66. So this is how we have used this row operations to arrive at this particular step. So if we were to write this step out in a clean manner, this is how it's going to look like. 1, -2, 3, -7. Then we have 0, 3, -7, 21. And then we have 0, 0, -22, and 66. So if we were to draw that partition line, and if we were to draw a line along the diagonal, we have achieved zeros below the diagonal. We want to make that location as equal to 1, and then we will proceed from that point on in here. To make that location as equal to 1, we're going to do the following operations. 1, -2, 3, 7, that is the first row. We'll get the first row as is. The second row, in the second row, we're going to do the following things. The new R2 is going to be equal to existing R2 divided by 3. So 0 divided by 3 is equal to 0. 3 divided by 3, that is equal to 1. -7 divided by 3, we cannot simplify that. I want to leave it as a fraction for a minute. And then 21 divided by 3, that is equal to 7. And the third row comes down as is, which is 0, 0, -22, and 66. So this is how we have. And then if we were to draw a line along this, okay, let me write this thing out in a neat manner here, which is 1, -2, 3, -7, then 0, 1, -7 over 3, and then 7, and then we have 0 0 negative 22, and then we have 66 there. So we'll draw this partition line here, and then if we were to draw a line along the diagonal, we have achieved zeros below the diagonal, we have achieved ones along the diagonal, and then we need to make this location as equal to 1, and then we will follow the row operations to achieve that. So to achieve that, we're going to do the following row operations: 1, negative 2, 3, negative 7. That is the first row, no change in there. The second row also comes down as is: 0 1 negative 7 over 3, 7. And the third row, in the third row, we're going to do the following operation. The new R3 is going to be equal to existing R3, row 3, divided by negative 22. 0 divided by negative 22 is equal to 0. 0 divided by negative 22, that is equal to 0. Negative 22 divided by negative 22, that is going to be equal to positive 1. And then 66 divided by 22, that is going to be equal to negative 22, that is going to be equal to negative 3. So if I were to write this one out in a clean manner: 1 negative 2 3 negative 7, 0 1 negative 7 over 3, 7, and then 0 0 1 negative 3. So we have the matrix in this augmented matrix format, and if I were to draw a line along the diagonal, we have achieved the low echelon process, and we had ones along the diagonal, we have zeros along this lower side of the diagonal, and we can from this augmented matrix solve for the variables x, y, and z. So from here we can write the system of linear equations from here on. So it looks as follows: x minus 2y plus 3z is equal to negative 7, and then y minus 7 over 3z is equal to 7, and then z is equal to negative 3. These are the three equations we have, and therefore we have the value of z equals to negative 3. That is one solution. We'll go back to the second equation and then find the value of y, and the way to do that is as follows: y minus 7 over 3 times negative 3, the value of z is negative 3, is equal to 7. So y, this 3 and this 3 cancels out. Negative times negative is a positive. 7 is equal to 7. Therefore, the value of y is equal to 7 minus 7, which is equal to 0. The value of y is equal to 0. That is the second part. And then we want to find the value of x. So we go back to the first equation: x minus 2y plus 3z is equal to negative 7. X minus 2 times 0 plus 3 times negative 3 is equal to negative 7. So 2 times 0 is equal to 0. So we have x minus 9, 3 times negative 3 is negative 9, is equal to negative 7. So therefore the value of x equals to 9 minus 7, which is equal to 2. Therefore the value of x equals to 2. We got the solution. So the solution here is x equals to 2, y equals to 0, and the value of z is equal to negative 3. We can go back, we can check our work by going back and then substituting it into the given equation. We will do one equation here. We can check any one of those equations, but you can we will come up we'll see that the values what we have on the left hand side will be exactly equal to the values what we have on the right hand side. So I'm going to take equation 1 and then check it. So the first equation we have is x minus 2y plus 3z is equal to -7. So we'll substitute the values of x, y, and z in here. X minus 2 times 0 plus 3 times -3 should be equal to -7. So let us see. So 2 times 0, this value goes to 0. So we have x minus 9 is equal to -7. So therefore the value of x equals to, we needed to substitute the values of x as well. So let me go back here. Let me go back and then redo this a little bit. Sorry about that. So the value of x is 2, the value of y is 0, 2 times 0, and the value of z is -3. And when we simplify that, that should equal to 7. So 2 times 0 is 0. So 2 minus 3 times 3 is 9 is equal to -7. So 2 minus 9 is -7 is equal to -7. So therefore the left hand side is equal to the right hand side, and therefore the values what we've obtained as x, y, and z, x equals to 2, y equals to 0, and z equals to -3 are exactly correct. So this is the way we want to be able to solve system of linear equations using matrix methods. In my next presentation, we shall look at some more examples related to solving system of linear equations using matrix methods.